What is the first derivative of y is equals to tan inverse quantity of e to the power x squared, or r tan e to the power x squared? So this is the same. Okay. Okay, to solve this, so let u is equals to e to the power x squared. Then we have du that is equals to e to the power x squared. Then we derive x squared. This will be times 2x. Okay. So take note that the derivative of tan inverse u, that is equals to du over, so 1 plus u squared y prime, that is equals to e to the power x squared times 2x over 1 plus the quantity of e to the power x squared to the power 2. Okay, so that is the final answer. Okay, so another example. So y is equals to cosine inverse 2 over square root of x. Okay, and so let u, that is equals to 2 over square root of x. Okay, so we can now remove this radical symbol so that we can derive and to find the du, no? Okay, so we let them into the numerator. Okay, so this will become 2x to the power negative 1/2. Okay, then derive to find du, so that is equals to 2 derivative of x to the power negative 1/2, so that is negative 1/2, then times x to the power negative 1/2 minus 1. So where du, that is equals to, this is negative x to the power negative 3 over 2. Okay, so take note that the derivative of cosine inverse u, that is equals to negative du over the square root of 1 minus u squared. Okay, so where y prime here is equals to minus or negative, substitute the equivalent du, that is x to the power negative 3 over 2. Okay, so over the square root of the 1 minus 2 x to the power negative 1/2. Okay, okay. Then finalize our answer. Okay, so this will become x to the power 3 over 2. So 2 times 2, this is 4, then over x. Okay, which is the square root of 1 minus 4 over x. Okay, so again, take note to simplify this. So we have 2, then we get the into the denominator, no? Okay, so we have changed to radical. Okay, then we have square here. So square 2 here, that is 2 to the power 2, and then the square root of x, or the 2 to the power 2 over the square root of x, or the quantity of the square root of x to the power 2, no? Okay, so we can now cancel the square root, or so that we can obtain this 4 over x. Okay, so this will be 4 for the numerator and then x for the denominator. Okay, then in this case we get, since this the negative exponent, so we can we can bring down those, then take the square root. Okay, square root of x cubed, then times the square root of 1 minus 4 over x. Okay, in this case we have the same index, the number of index, no? Okay, so, or the square root or radical symbol. Okay, can multiply both radical, no? Okay, so we have 1 over the square root of x cubed, then times 1 minus 4 over x. Okay, then so this is 1 over the square root of x cubed, then minus 4x cubed. This will be, since we have the denominator of x, which is the exponent of x is 1, so this will be 4x squared. Okay, so by the way, this is the final answer. This is the first derivative. Okay. So again, we come up with this answer: 1 over the square root of x cubed minus 4x squared. Okay. Okay, so we have another example. Y is equals to 4x sine inverse the quantity of ln 3x. Okay, so since the given is we have a product, no, or we think that we use a product of, or the product formula of derivatives. Okay, since we have 4x, then another is sine inverse ln 3x. Okay, so in this case we have u is equals to 4x, then du here, that is equals to 4. Okay, so v here, that is equals to sine inverse, okay, then ln 3x. Okay, so to find dv, okay, so we have dv here, so take note that the derivative of ln u is equals to du over u. Then another is the derivative of sine inverse, okay, u, that is equals to du over the square root of 1 minus u squared. Derive ln 3x, so we have the derivative of 3x, that is 3, and then we have the u, or this can be 3 over 3x, okay, or that is equals to 1 over x. Okay, and that is our du. Okay, in this case. Okay, so again, let's review. So we consider u sine inverse u, that is our ln 3x, and then when we derive 3x ln 3x, that is our du. So 1 over x. Okay, so this can be 1 over x, then over the square root of 1 minus the quantity of ln 3x and squared. Okay, so substitute. So therefore our first derivative, so again, since this the product given, and then we use the product formula of the derivatives, no? Okay, so this is uv is equals to u dv then plus v du. So we obtain the first derivative, that is equals to the 4x, then we have the 1 over x over the square root of 1 minus ln squared 3x. Okay, then plus 4 sine inverse then ln 3x. Okay, so again, wherefore here is our du, since the formula is v du. Okay, so we can now to obtain the, or to finalize our answer, that is equals to, since this x here for x and 1 over x, we can cancel. Okay, so 4 over the square root of 1 minus ln squared 3x, then plus 4 sine inverse then ln 3x. Okay, so that is the final answer. Okay, so we have another example. So what is the first derivative of cotangent inverse the quantity of 5 to the power 3x? Okay, then solid du here, that is equals to 5 to the power 3x, then du here. Okay, so in this case, we use this formula, that the derivative of a to the power u, and that is equals to a to the power u then ln a, then we have du here. Okay, so this is 5 to the power 3x then ln 5 then times 3. Okay, for the derivative of 3x, that is 3. Okay, so again, the formula of the derivatives of cotangent inverse u, so that is equals to the negative du over 1 plus u squared. Y prime, or the first derivative, that is equals to negative, then we substitute the equivalent of du, so which is 5 to the power 3x then ln 5 and times 3. Okay, then over the 1 plus quantity of 5 to the power 3x then square. So that is the final answer. Okay, so another example is y is equals to e to the power ln 2x then secant inverse and secant x. So let u here as our this, no? Okay, then v here, so we have a to the power ln 2x. Okay, then where du here, that is equals to the e to the power ln 2x. Okay, then the derivative of ln 2x, so that is equals to then we get the chain rule, no, or we apply the chain rule. So the derivative of ln 2x, then we also derive the 2x, no, so we have 2 over 2x. Okay, so where du here, that is equals to e to the power ln 2x then over x. Okay, so again I use this formula since we can derive this. Okay, so take note, e to the power u d that is equals to e to the power u du. Okay, and so that we can obtain the du equivalent, no. Okay, so and this is the equivalent of du, e to the power ln 2x over x. So we can cancel these two. Okay, so for v, which as secant inverse, then secant x. Okay, so again take note, the derivative of the secant inverse, so that is our secant inverse u, that is equals to du over the absolute value of u, this times the square root of u squared minus 1. Okay, so to find dv here, where dv, that is equals to again we have in this case the v equivalent, we also apply the chain rule, no. Okay, so since in this case we considered as u, no, so take note that the derivative of secant u that is equals to the secant u then tan u then du. Du here, that is equivalent of secant x. Okay, secant x then tan x. Okay, so the derivative of x is 1. Okay, then where u here, that is equals to the secant x, the absolute of secant x, then the square root of the secant, the quantity of secant x to the power 2 then minus 1. Okay, so that is the equivalent of dv. Okay, so again, since the given is a product, so you must take the formula of the product rule and the derivatives. Okay, so again, this is the product formula of derivatives. So u v is equals to u dv plus b du. Okay, so now we can substitute. So where u here, that is equals to the e to the power ln 2x then we're dv here, and then we can multiply, no, then substitute also the dv equivalent. So we have secant x then tan x over the absolute value of secant x then the square root of the secant squared x, then minus 1. Okay. Okay. Then plus where b is equals to secant inverse of the quantity of secant x. Then times du s equals to e to the power ln 2x over x. Okay, so in this case we must simplify. So take note that to simplify this, no, okay, so in trigonometric identities, so tan squared theta is equals to secant squared theta, then minus 1. Therefore we have tangent squared x, and that is equals to secant squared x, no, then minus 1. Okay, so write or rewrite, so y inverse, that is equals to e to the power okay, so e to the power ln 2x, then secant times the secant x, then we have tan x over the quantity or the absolute value of secant x, okay, then the square root of the, okay, so we have the equivalent of this, which is this, no, okay, so therefore this is tan squared, the square root of tan squared, no, okay, then x. So plus the secant inverse quantity of secant x, then we have times the e to the power ln 2x over x. Okay, so next, since we have the square root here, tan squared x, so we can now cancel, so that we can obtain tan x. Then secant x, then we have in numerator we also secant x, so we can now cancel. Then again in this case, then in terms of e to the power ln 2x, so take note that e to the power ln, that is equals to 1, or e to the power ln that is considered as equals to 1. Okay, so we can also cancel, then then we have y is equals to 2x, then the numerator is, we have tan x, so we can now cancel, so therefore that is equals to 1. Then okay, so tan x over tan x, that is 1. Okay, so plus we focus on this. Okay, so we have the secant inverse, then quantity of secant x. Okay, so we have 2x over x. Okay, so to finalize our answer, so y prime is equals to 2x, then plus we can cancel also x over x, no, and that will to obtain 2 or to remain 2, no, So we have 2 here, then secant inverse the quantity of secant x, no? So that is the final answer.